Okay, we are going to continue talking about function notation, but this is with equations. So this is, remember, x is your input. So we are going to input a number or something in for x and then solve. Whatever comes out is your output. So this is the same as y. And this is, I don't know, because I just messed up on that one because I got excited. This is your actual function. That one's terrible. I don't know what happened.
Oh.
There, it should have been like that. Anyway. See, it doesn't come out perfect every time. All right, so let's look at this first box here. It says evaluate the function. So the first one says f of a smiley face. We need to find out what that is if this is our function. So that means we need to input this for x. So we're going to do 4 smiley face minus 1. That's all we can do on there. We can't simplify anything. So we're going to leave it just like that. Okay, so then the next one we have a triangle to input for x. That's 4 triangle minus 1. So whenever you have an equation, you're just inputting whatever is in that x spot. The next one, we have a star. Or the only star that I can make is one that's all connected like that. Minus 1. So all three of those are just examples on where it goes, where it's being inputted. So then number 4, we have a number this time. So we are going to input 3. Do what? Parentheses. So whatever's in the parentheses is going to be what you're going to input for the x value. So this will be 4 times, I'm going to put it in parentheses still, 3 minus 1. We can use our calculator if we need to, or we can do this in our head. 4 times 3 is 12. 12 minus 1 is 11. Okay, so then what if we have 5 as our x? We're going to input a 5. So 4 times 5 minus 1. Yep, 4 times 5 is 20. 20 minus 1 is 19. The next one, we have negative 2 for x. So 4, so instead of writing x, I'm going to put a negative 2 minus 1. Yeah, because this is negative 8 minus 1. Keep, change, flip. So that's negative 8 plus a negative 1, which is negative 9. And we can use our calculator for this. Okay, we are going to do this next one where we have f of x and g of x. So we are just going to input those values. I believe these are zeros. They just kind of look a little funky. Right there. They were just a little messed up. Okay, so let's look at it, and then we are going to plot the points to make each one of our lines. So we're going to start with the f of x first. So we are going to input, so it's going to be 3 times a negative 2 plus 2. So that's a negative 6 plus 2 equals negative 4. Then the next one we have negative 1. So we're going to do 3 times a negative 1 plus 2. 3 times -1 is -3 plus 2. They are different signs, so we're going to subtract them. 3 and 2 are 1 apart, and we keep the sign of the larger, so it's -1. And then we have 0. So 3 times 0 plus 2. This becomes 0 plus 2 is just 2. Then 3 times, this is inputting 1 plus 2 equals 3 plus 2 is 5. Okay, so before we go on to g of x, we are going to draw this function. And the way you draw the function is use the coordinates. So yesterday on your homework, you were asked to plot some points. So if you have this is your x value, and whatever you come out with is your y value. So I'm going to write the points right here. So this point is -2, -4. Because x is -2, y is -4. So the coordinate is -2, -4. So we're going to plot that on our coordinate grid. I know some of y'all still struggle with plotting. So we are going to look at quadrant 1 right here is your positive. Quadrant 2 is -. Quadrant 3 is negative. And quadrant 4 is positive. So if I have the coordinate of -2, -4, that's going to be in the negative quadrant. So I'm going to go -2 over, -4 down. Okay, so that's my first point. Okay, the next point, we have -1 with -1. So that's the next point, -1, comma, -1. So this is another negative. So it's going to be in quadrant 3. So -1, -1. The next one is 0, 5. So that means it's on the 0 on the x-axis.
Why'd you put 5?
Oh, I don't know. 2, I've seen if y'all are paying attention. Okay, so 0, 2. So it would be, you wouldn't go left and right any. You would just go up to 2. I think I was looking down at the next one, maybe. Then the next one is 1, 5. So over 1, up 5, because it's in quadrant 1. 1, 2, 3, 4, 5. Okay, remember how I told y'all to buy rulers at the beginning of the year? So we're going to start using those.
I never could find a 6-inch ruler, so I got a 12-inch.
That's fine.
That's at my house.
Somebody cut one the other day.
That's the one like
That one?
It's
6 inch though.
You can just find that one ruler.
No, they're all out though.
Yeah, what?
They really were. What's that?
So, I don't know. That is not. This is a ruler, man. I don't know where you got that.
Okay, so you are going to graph that, and I'm going to put right beside it, or at the top, f of x. So that I know that's the f of x. Then I'm going to use different colors for g of x. Okay, so this is a function, and this is a linear function because it creates a line where you connect it. So f of x is linear. It's also continuous. The arrows mean it goes on and on forever. Forever. Okay, so go ahead and do g of x now by yourself and graph it.
What is not a straight line?
It should be. It will be a straight line.
2x plus what?
2x plus 1.
Plus 1?
If you're not sure, I'm going to go ahead and work them out.
Do we draft it?
Yes, you graph it. Okay, so you can go ahead and check yours with mine now. I haven't graphed mine yet. So I'm going to do that next. So -2, -3 is on the negative negative. So -2, -3. And then I have -1, -1. So that's in -1, -1. So they share a point, right?
Yeah.
Okay, and then 0, 1. And then 1, 3. So this is the g of x. Okay, thumbs up if you got this right. Good. Kinda. That's good. Okay, so one thing I do want to mention is we could also do this in the calculator. So everybody go to y equals in the calculator. And we are going to graph this. So go to y equals, plug in 3x plus 2 for y1. And then g of 2 is going to be your y2. So 2x plus 1. So you have y1 and y2 on there. And then I can look at the graph or I can look at the table. So I'm going to hit graph first. There's your first line. And there's your second line. Looks the same. So to know which one's which, you can go back and see, okay, the blue one is going to be my y1. That's the one that I graphed first. It's this one. The red one is going to be my y2, which is the second one. So that way you can look at it a little better to know which one's which.
The line is black and white.
Oh, if you have one of these calculators, it's colored. One of the class set. But if it's just yours, it's It's not black. It's just black and white. You're right. All right, and then the table. We can go to second graph, which is your table of values. And we can look and see, okay, if we're at -2, it's -4 for the first one, but -3 for the second one. And then -1, 1, -1, -1. Yep, that's point of intersection because they share that. Okay, and then 0, 2, and 0, 1. 1, 5, and 1, 3. Okay, so let's go to the last part, which just says evaluate. So we are just going to plug in the x value. So go ahead and do that by yourself. You can use the calculator or you can do it by hand.
So for the x, put 2.
Yep, for the x, put 2. And make sure you pay attention. If this is f, then you use the f function. If it's a g, then you're going to use the g function. If it's both, ooh, that's fun. I'm going to show y'all. Yeah. So do 1 and 2. Those don't have anything special to them. Okay, and then g of 3 is x 3 plus 3. Just gives you 6. Okay, so now this is where it gets fun. Yay, so much fun. All right, f of g of x. So that means in the place of x, I'm going to plug in g of x. G of x is x plus 3. So I'm going to do it the same way. So 2, but instead of putting x, I'm going to input what's right there. And that says g of x. So g of x is just x plus 3. So I'm replacing the x with what g of x is.
So you can't really work that one out?
We can simplify it. But what about left off? 2 times x minus 1. We can simplify it. So that means I'm going to distribute 2x plus 6 minus 1. And the only thing that you can simplify is a 6 minus 1. So it's 2x plus 5. Okay, and then this next one is the other way. We have the g outside and f of x on the inside. So that means where I see the x for the g, it's x plus 3. But instead of writing x, I'm going to input this 2x minus 1. So 2x minus 1, because it's x plus 3, right? So this is x. And this is going to be plus 3. So this is just 2x minus 1 plus 3. So I can combine these. -1 plus 3. What is that? Yeah, 2. So it's 2x plus 2. Kind of crazy. Okay, the next one, we have f of g of 3. So remember yesterday how we had to do the innermost parentheses first? So we need to find out what g of 3 is. Have we done g of 3 yet? Wasn't that up here?
Yeah.
Yeah, so to get that, we just plugged in 3 into the g function. So that means this is f of g of 3 is 6. So I kind of skipped a step because we had already done that. So equals, now what is f of x?
Well,
2x minus 1. So I need to do 2 times x, 6, minus 1. Because my function is 2x minus 1. So that's 12 minus 1, which is 11. Okay, so what about the next one? We have g of f of 2. We've done f of 2. What was f of 2? 3. We've already done that. So that helps us there. So it's g of 3, which is what? 6. Yeah, because it's x plus 3, which just equals 6. Okay, you're going to cut this out just in that L shape, and we're going to put it in our journal.
These are glued together. Someone glued these together.
What do you say?
And we will go to page 38, and we're going to put this in our journal.
Yeah.
Okay, you're going to fold this side like that so that it fits.
Why didn't you fold it all the way?
Because I can just do like that.